Welcome to the demo of the EOSC Execution Framework and the Integration Suite. You will see how a JupyterHub environment can be deployed from the EOSC Front Office and integrated with repositories and a cloud data store thanks to an EOSC adapter. We begin by searching in the Deployable Services list and select JupyterHub from the available offers. The service description provides technical information, classification, provider details, and a direct link to the TOSCA template that defines the cloud topology. Opening the template, we can inspect the components of the infrastructure. From a typical JupyterHub deployment, this one has been extended in two aspects: to pre-load datasets when the service starts, given the dataset's DOIs, and to include the Jupyter Data Access adapter to allow the sharing of data with external data stores. The Jupyter Data Access is one of the adapters you can find in the EOSC Discovery Hub. Back to the deployable service, let's log in to request the deployment. We can now specify the infrastructure parameters, like the number of CPUs, storage sizes, and so on. We also add the list of dataset DOIs corresponding to research datasets to include in the deployment. The datasets are hosted in external open access data repositories. Once everything is filled in, we submit the order. The request is sent to the service provider and becomes visible in the Infrastructure Manager dashboard. The Infrastructure Manager composed the final TOSCA template and handles the provisioning of virtual machines on the target cloud site, in this case, the IISAS Fed Cloud provider. As a quick detour, we can inspect the deployment in the provider's cloud dashboard. Several machines have been created. Back in the front office, we can see that our deployment is ready, and we can easily access our JupyterHub by clicking on the blue button. We can log in using the credentials defined previously in the request form. Inside JupyterHub, we can see that our workspace contains 5 biodiversity datasets from LifeWatch, ready for analysis. The system has automatically downloaded the datasets behind the DOIs we specified in the request form. Next, we open a Jupyter Notebook to proceed with our data analysis example. The analysis goes through loading, cleaning, computing, and visualizing data. Eventually, it generates output files, tables, and plots illustrating the results of the analysis. Once the analysis is complete, we use the integrated Jupyter Data Access adapter to connect to an external Amazon S3 bucket. In the adapter widget, we select the type of data storage and enter the required information to connect and mount the bucket in our environment. We save the output files, for example plot figures, directly to the remote storage. To double-check that, we can go to AWS's console and see the files transferred. The infrastructure can be shared with colleagues, who can perform different analyses and progress with the research activity. Once the collaborative analysis is concluded, we can free the resources. With the integration suite and the execution framework, researchers can quickly set up an infrastructure for collaborative data analysis.